Hi guys, and welcome back to the ACE Academy. In this video, we will be looking at how to sketch an exponential function using a given equation, as well as how to find the equation of a given sketched exponential function. In the first part of this video, we will be focusing on sketching the exponential function using the list of exponential equations on the screen right now. Looking at the function of f of x, this has the equation f of x is equal to 3 to the power x plus 1. And we want to sketch this on a blank Cartesian plane. To do this, I will first identify my horizontal asymptote, which in this case would be positive 1, as you can see right here. So I'm going to go ahead and sketch in that horizontal asymptote. This horizontal asymptote has the equation y is equal to 1, so I will label it as such. My next step would be to identify the shape of this function and identify my a and b values. As you can see, this is a positive number. It is a positive 3, which means my a value would be equal to positive 1, and my b value would be equal to positive 3. Now, when I look at my a value being a positive number, I must immediately realize that this function is going to lie above its horizontal asymptote. That's my first step in identifying the shape of an exponential function. I then want to see whether this function is going to be increasing or decreasing. Now, if you guys can remember in the previous video, if you guys can remember, in the video on shape for the exponential function, I explained to you guys that when the value of a is positive and the value of b is greater than 1, we are going to get an increasing function above the horizontal asymptote. Another important point that I need to take note of is my y-intercept. We know that the y-intercept of an unshifted exponential function is at positive 1, because any base raised to the power 0 is equal to 1. But remember guys, now we have a vertical shift that has been induced. So where previously my y-intercept was at positive 1, I will now add 1 to that because my entire function has been shifted up by 1 unit. So my new y-intercept would be at y is equal to 2. So I'm just going to label that and put a point on y is equal to 2. Okay. Then taking into consideration the shape of this function, I know it's going to be increasing. So I can go ahead and draw that in. And there you have it. That is the exponential function for the equation f of x is equal to 3 to the power x plus 1. I'm just going to go ahead and label this so we know which function we are looking at on the screen. So I will label it as f of x. Moving on, we are now going to look at the function g of x, which has the equation g of x is equal to negative 2 to the power x plus 1. The first thing I'm going to do is identify my horizontal asymptote. And as you guys can see, that would have the equation y is equal to positive 1. I already have that sketched for me right here. I'm just going to indicate it with a little dash red line so we know which asymptote we are working with. The next step would of course be to identify the shape of this function. So let's look at the a and b values for this function. We can see that because of this negative sign right here, my a value is going to be negative 1. We can also see that because 2 is the base for the exponent x, b would be equal to 2. Now let's go ahead and take a moment to identify the shape of this function. A is going to be negative, which means my function is going to lie beneath my asymptote. We can also see that b is a positive number and it is greater than 1 because 2 is greater than 1. Now if I pair those two values together, I would understand that my function would be beneath the asymptote and it would be decreasing in nature, which means it would start off close to your asymptote and it would deviate, going further and further away from your horizontal asymptote as it progresses in your x values. Now another point I want you guys to take note of is that when the value of a is negative, meaning your function is flipped over the horizontal asymptote, without a vertical shift, its y-intercept would now be negative 1. Now introducing the vertical shift into this equation, we will see that our new y-intercept will be where y is equal to 0. So I'm going to go ahead and plot that point. I can then go ahead and sketch in the function. And there you have it, guys. This is the function of g of x, which is equal to negative 2 to the power x plus 1. Now let's go ahead and look at the function of h of x, which has the equation h of x is equal to 1 over 3 to the power x minus 2. The first thing I'm going to look for is, of course, going to be my horizontal asymptote, which has the equation y is equal to negative 2 as indicated by the q value. So I'm going to look for negative 2 and sketch in the line y is equal to negative 2. We are now going to go ahead and look at the shape of this function. We can see that a is positive because the base is positive. So a would be equal to positive 1. Now looking at the b value is actually equal to 1 over 3. And 1 over 3 is a fraction, which means it is less than 1 but greater than 0. So combining those two attributes of this function shape, we can see that this function will lie above its horizontal asymptote, and it would have a decreasing nature, which means it would start off away from your horizontal asymptote and it would approach it as you progress in x values. So I can go ahead and sketch that in. But I want to take note of the y-intercept first, where this function would usually have a y-intercept of 1 because it's positive. If I subtract negative 2 from it, because that was our horizontal shift 2 units downwards, I would get an answer of negative 1. So I'm going to go ahead and plot that in. And then I'm going to go ahead and sketch in this function. And we can see as this function progresses from left to right, it gets smaller and smaller in terms of y values, which makes it a decreasing function. This would be the function of h of x, so I'm going to label it as such. We are now going to go ahead and plot the function k of x, which has the equation k of x is equal to negative 1 over 4 to the power x plus 2. Now, in order to sketch this function, I would of course first need its horizontal asymptote, which is given by the equation y is equal to positive 2. So I'm going to look for where positive 2 is, and I'm going to estimate and draw in a horizontal asymptote, which, as you can see, is indicated by the yellow line on the screen. Now that I have my horizontal asymptote, I'm going to label it. My next step would be to identify this function shape. Looking at the a value, that would be negative 1 because of the negative sign associated with 1 over 4. And looking at the b value, it should be 1 over 4 or a quarter. And a is negative 1, which means that this function would be situated beneath its horizontal asymptote. Now, if I'm applying both of these attributes together, I would know that this function is going to lie beneath this horizontal asymptote, and it would be increasing in nature, meaning it would start away from the horizontal asymptote and it will progress closer and closer to the horizontal asymptote as you progress in x values. So my next step, of course, would be to identify its y-intercept, which, if I am looking at a negative number, should have been at negative 1. A negative a value, I would have had I would have had a y-intercept at negative 1. But now I'm going to apply the vertical shift to it. And applying the vertical shift to this function, I would have to add 2 to that negative 1, which gives me a y-intercept of positive 1. So I'm going to go ahead and plot that in there. I hope you guys can see it. Okay, and then I'm going to go ahead and plot in the shape. As I said, this would start further away from the horizontal asymptote and will progress towards the horizontal asymptote as the x values increase. And this would be the function of k of x. Now, I know that there's a number of functions on this single Cartesian plane, but I want you guys to differentiate it by color so that you can see it a bit easier. And notice how the a values and b values manipulate the shape of this function, and also take note of whether the function is increasing or decreasing. Please be aware of the fact that the y-intercept changes with a vertical shift. It will just be shifted in the same way that the function is shifted. For example, in the first one, the function was shifted 1 unit upwards, where previously the function's y-intercept would have been at positive 1, it would now be at positive 2. Understand? It's that simple, guys. Moving on. In this part of the video, we are now going to look at obtaining the equation of an exponential function using the given sketch. So on your screen right now, you guys have two different exponential functions that are sketched. And you can see very clearly that the asymptotes have been given for both exponential functions, indicated here at y is equal to 3 and at y is equal to -1. We then have one point on each exponential function that is given. Another bit of information that we have is its y-intercepts. As you can see, it's indicated there. So using these few bits of information, we are able to obtain the equation from these functions. Looking at the graph of f of x, which is highlighted in yellow right here for you guys, as you can see I indicated it here as f of x, we are going to obtain this function's equation. So our first step when working with any exponential function or any function, regardless of what type of function it is to write down its standard form. So for the exponential function, it would have the standard form of y is equal to a times b to the power x plus q. Okay, now looking at this yellow function on your screen right now, we can see that the q value is going to be -1 as indicated by your horizontal asymptote for this function. So we can rewrite this equation and substitute in -1 for p, and we would get y is equal to a times b to the power x minus 1. That is our first step to write in the value of q. Now, in order for us to obtain the value for a and b, we are going to look at the function shape, and we are going to use the point that is given on this function. Okay, keep in mind, guys, that these functions have not been drawn to scale. This is an empty Cartesian plane, and I know that the proportions aren't correct on the screen right now, because over here, as you can see, this is -3 and 26 at this point, and it's way below the 3 line, the line of equation y is equal to 3, and that's because I just quickly sketched this down. So don't worry, it won't affect our calculations, okay? Looking at this function shape, we can see that it lies above the horizontal asymptote. That's the first thing I want you guys to take note of with regards to shape, which means our a value would be positive. And this function has a y-intercept at the equation y is equal to 0 or x is equal to 0. At the coordinate x is equal to 0, y is equal to 0. So in the first video, I mentioned to you guys that x would usually be a +1 or a -1. In this case, it would be positive because it lies above the horizontal asymptote. So I can make a note of that. I can say y is equal to +1 times b to the power x minus 1. And as you can see, that +1 does not affect my calculations, because when I multiply anything by a +1, I would get that same answer. Okay, in order to obtain a value for b, we would substitute the point that has been given on this function, and that would be an x value of -3 and a y value of 26. So let's go ahead and do this quickly. We would get 26 is equal to b to the power -3 minus 1. Let's go ahead and manipulate this equation so that we can solve for b. We would obtain 27 is equal to b to the -3. In order to simplify this part of the equation, we can do it quite simply, but I'm sure that you guys aren't used to working this way, so I'm just going to show it to you guys firstly. We know from our laws of exponents that a negative exponent means it's in the wrong position, where in fact this is in the numerator right here. It should be in the denominator with a positive exponent. So if I rewrite that, I would obtain 27 is equal to 1 over b to the power 3. And we are not solving for 1 over b to the power 3, guys. We are solving for b. So in order to do this, I will multiply both sides by b. And I would b to the power 3. I would obtain b to the power 3 times 27 is equal to 1. And then to get rid of that 27, I would divide both sides by 27. And I would obtain b to the power 3 is equal to 1 over 27. Now, I'm not solving for b to the power 3, guys. I'm solving for b. So in order for me to do that, I would cube root both sides, and I would get b to the power 3 under a cube root sign, which would be equal to the cube root of 1 over 27, and therefore I would obtain the equation of b is equal to 1 over 3. It's a fraction, and that makes sense because this is a decreasing function above the horizontal asymptote. So I can put this all together and obtain the equation for this function, the function of f of x. And that would simply be f of x is equal to positive, and I don't have to indicate the 1 or the positive because by nature the function should be positive, right? It should be positive 1 over 3 because we just worked that out to the power x minus 1. That's the value of our horizontal asymptote. And that's how you would obtain the equation for the yellow function, the function of f of x. Right, guys? Now, I'm going to give you guys a few seconds just to take that down. You can pause the video, and then we would continue with the function of g of x, the graph of g of x. Okay, guys, we are now going to obtain the equation for the green function, which is the graph of g of x. Now, using the standard equation that we wrote down earlier, we can see that positive 3 is the horizontal asymptote for this function. So I can replace the q value in this equation with a positive 3, and I would get the equation g of x is equal to a times b to the power x plus 3. In order for me to obtain the value of a, I'm going to look at the shape of this function. And we can see that the function lies beneath its horizontal asymptote, which tells me that the a value is going to be negative 1. Now, in order for me to obtain the value for b, I'm going to substitute in a known point, and I would then manipulate until I get b alone to obtain its value. So we have the point 2 and negative 6, and we are going to substitute that into this formula. So negative 6 will be substituted in for g of x, and that would be equal to negative 1 times b to the power 2 plus 3. We can manipulate this equation further by removing the constant. I'll bring it over the equal to sign, and that will become negative 9, and that is equal to negative 1 times b squared. Right? And for me to get rid of this negative sign, because I want to get b squared alone, I would divide both sides by negative 1, and I would obtain a positive 9 is equal to b squared. I can then square root both sides, and I would get the answer of b is equal to 3. Now, using those bits of information that I've just found, I can write in the standard formula. So g of x would be equal to, I know that a is going to be negative 1, so I will just indicate it with a negative sign. Then I know that my b value is going to be 3, so that would be 3 to the power x. And then my q value is positive 3, so I'd indicate it with a positive 3. And that is the equation for the function of g of x. It's that simple, guys. All the best, and I will see you in the next one.